Welcome to Dreamtime Science, where curiosity meets tranquility and knowledge flows like a gentle stream. Here we explore the wonders of our universe at a pace that soothes the mind. You know what's fascinating? I've been thinking about how every color, shape, and movement we see isn't just out there in the world. It's something our brain carefully puts together from tiny flashes of light. There's something remarkable about how this quiet, invisible process creates the rich, colorful reality we experience every day. And I can't wait to share how it all works in tonight's Dreamtime Science. Your support through likes and subscriptions keeps this tranquil laboratory of knowledge glowing softly. Tell me in the comments what scientific concept has always fascinated you. Take this moment to settle in, wrap yourself in comfort, release the day's weight from your shoulders, and let your breath become as gentle as starlight. Once upon a time, before the first words were whispered around fires, before the first brushstroke decorated a cave wall, there was only darkness and the flicker of possibility. In that primordial hush, light had already begun its endless journey. It danced across the void, a restless caravan of photons, born in the depths of ancient stars, flung outward on waves older than memory itself. The story of vision, of seeing and being seen, begins with these travelers, each an emissary from a faraway place, each carrying the potential to ignite worlds of meaning in our minds. Light. It is a word so simple, so familiar, that its true strangeness often escapes us. But what is a photon, really? In the language of physics, it is a quantum of electromagnetic radiation, a particle without mass, at once a particle and a wave. It slips through space at a speed so vast it strains the imagination, nearly 300,000 kilometers every second, or, if you prefer, over 7 times the circumference of Earth in the blink of an eye. Every second, quadrillions upon quadrillions of photons pass through the world around you, bouncing from leaf to stone, from skin to river, from the face of a loved one to the silent surface of your eye. Our eyes are but one link in the great chain that connects us to this cosmic dance. Yet, even before biology, before the evolution of sight, early humans must have wondered, what is it to see? The night sky, pricked with stars, was an invitation to myth. The Cyclops of ancient Greek legend, with his single burning eye, was both a monster and a mystery. Why one eye, and not 2? Why any eyes at all? In the Cyclops' gaze, there was the condensed terror and fascination of vision distilled to its barest form, a single, unblinking portal to the world. The Cyclops was not alone. In every corner of culture, the act of seeing has been wrapped in stories. The Norse gods plucked out eyes in exchange for wisdom. The Egyptians adorned their tombs with the Eye of Horus, a symbol of protection and power. Across time, the eye has stood at the border between the inner universe of thought and the shimmering, ever-changing outer cosmos. To see is to know, to be awake, to be alive. But set aside myth for a moment and turn your attention to the photons themselves, racing across the unimaginable gulfs of space. Consider the sun, a churning sphere of hydrogen and helium, fusing atoms in its core, releasing energy that, after a 1,000,000-year sojourn through the star's dense interior, finally bursts free as light. That light, some of it, travels for 8 minutes and 20 seconds before it reaches Earth. In that time, it is unchanged, silent, a pure possibility. As you sit, wherever you are, perhaps with your eyes closed, the photons that illuminate your world have been on a journey. Some have ricocheted off walls, off the pages of books, off the petals of flowers. Some have travelled from distant galaxies, their energy stretched and faded by the expansion of space itself, arriving as the faintest whispers of starlight. Most, though, are children of our own sun, reflected and scattered by atmosphere and cloud, filtered through leaves and glass, finally arriving at your eyes. The eye, that remarkable organ, is a window, yes, but also a gate, a filter, a living interface between the chaos of photons and the ordered world we perceive. The human eye is a marvel of evolutionary engineering, shaped over hundreds of millions of years. Its surface, the cornea, curves with exquisite precision, bending incoming rays just so. Behind it, the lens, suspended by delicate fibers, fine-tunes the focus, adapting moment by moment as you shift your gaze from horizon to hand, from the infinite to the intimate. Within the eye, at the far end of this tunnel of transparency, lies the retina, a thin sheet of cells, barely more than a whisper in thickness, yet dense with photoreceptors. These are the rods and cones, each a tiny antenna tuned to a particular frequency of light. Rods, sensitive to the faintest glimmer, open the world of night vision. Cones, in 3 varieties, allow us to perceive the riot of color: red, green, blue. It is only here, in the darkened chamber of the eye, that the journey of the photon reaches its end. Imagine for a moment the photon's final passage. It slips through the cornea and the lens, threads its way through the clear jelly of the vitreous humor, and lands, at last, upon a photoreceptor. Here, in the silence of the retina, a single molecule, rhodopsin in the case of rods, absorbs the photon's energy. Instantly, the molecule twists, an infinitesimal contortion, and this act sets off a cascade of electrical changes. What was once light becomes signal, a train of impulses that will race down the optic nerve toward the brain. But the journey is not yet complete. For vision is not a mere recording of photons, like a camera capturing a scene. It is a process of interpretation, of construction. The brain, in its darkness, never sees the world directly. Instead, it receives patterns of electric pulses, a code that must be deciphered. It is here, in the occipital cortex at the back of your head, that the world is conjured anew, edges sharpened, colors woven, motion detected, faces recognized. The reality you experience, the seamless panorama of sight, is an act of creation as much as it is an act of reception. Consider now how fragile, how contingent this miracle is. There are those for whom this chain is broken, by birth, by accident, by time. Some are blind, and their experience of the world is shaped entirely by the senses that remain. Yet even here, the imagination finds ways to bridge the gap. In the world of science fiction, vision is often reimagined, extended, reshaped. Think of Geordie LaForge, the blind engineer from Star Trek, whose iconic visor translates a spectrum of electromagnetic radiation into neural signals his brain can interpret as sight. The visor is both technology and metaphor, a reminder that seeing is not bound to biology, that perception is a story we tell ourselves, crafted from the raw material of sensation. In the real world, too, technology now reaches into the domain once reserved for myth. Bionic eyes, retinal implants, and sensory prostheses have begun to restore fragments of vision to those who have lost it. These devices, still crude by the standards of nature, are a testament to the human desire to see, to know, to be connected to the world. They are also an echo of the ancient mythologies, where vision is power and the gift of sight is both blessing and burden. But let us turn back once more to the photons. For even as we build devices to capture or extend sight, we remain bound by the laws that govern light's behavior. Photons are elusive. They do not possess mass, and so they are not constrained by rest. They oscillate in electric and magnetic fields, traveling in straight lines unless deflected by matter or bent by gravity. When they encounter an object, they may be absorbed, ceasing to exist in their original form, or reflected, scattered, refracted. Every surface you see, every color, is the result of this interplay. The red of an apple is not inherent to the fruit itself, but a consequence of which photons are absorbed and which are reflected, which reach your eye and which are lost to the world. This raises a subtle and profound question. What is color? Is it a property of objects or a creation of the mind? The answer, as so often in science, is both and neither. Color is the result of specific wavelengths of light, yes, but it is also the product of your neural machinery, tuned by evolution to discern differences that once mattered, ripe fruit from bitter, predator from prey, friend from stranger. The world, as you see it, is a collaboration between physics and perception, between the indifferent laws of nature and the urgent needs of life. Throughout history, artists and scientists alike have been fascinated by this collaboration. Newton, experimenting with prisms in the quiet of his rooms, discovered the spectrum, white light, split into its constituent colours, a rainbow conjured from the ordinary. He named the colours, though the boundaries between them are as much invention as discovery. Later Goethe would argue that colour was not merely a matter of physics, but of context and contrast, of the way the eye and mind conspire to create meaning. In the realm of myth, colours are often imbued with symbolism, the blue of the sky as the domain of gods, the green of spring as the promise of renewal, the red of blood as the currency of life. In science fiction, color can be a signal of the alien, the unknown. Think of the shimmering, unnatural hues of distant planets, or the eerie glow of a transporter beam. Each culture, each story, uses color as a language, a way of encoding values and fears, hopes and dreams. Yet for all the richness of vision, there is so much we cannot see. The visible spectrum, the range of wavelengths our eyes can perceive, is but a tiny sliver of the electromagnetic continuum. Longer wavelengths become infrared, felt as heat but unseen. Longer still, and you enter the domain of radio waves which can pass through walls and across continents. Shorter wavelengths become ultraviolet, then X-rays, then gamma rays, energies too fierce for our eyes, but which reveal hidden worlds to the instruments we have built. Think of bees, who see patterns in flowers invisible to us, or snakes, who sense the warmth of prey in the dark. Think of telescopes that peer into the radio sky, or satellites that map the Earth in infrared. Every extension of sight is an expansion of our understanding, a reminder that the world is richer and stranger than we can grasp unaided. And yet, for all its limitations, human vision is a wonder. The eye, in its compact elegance, distills the riot of photons into coherence. The brain, sculpted by eons of evolution and shaped by a lifetime of experience, transforms signals into scenes, raw data into story. To see is not merely to detect light, but to participate in a centuries-old collaboration between nature and culture, between the outer world and the inner self. As you lie in darkness, perhaps you notice the after-image of light behind your closed lids, the gentle play of phosphenes, those flickers born of the restless firing of neurons. Even without photons, the machinery of vision hums on, eager for input, ready to interpret and create. The dance of photons continues outside, unchecked, a silent ballet of energy and possibility. In the quiet that follows, consider this. Every time you open your eyes, you participate in a process that began in the hearts of stars. Every color, every shape, every movement you perceive is the culmination of a journey billions of years in the making. The art of seeing is not a passive act, but an ongoing dialogue between the universe and the mind, a conversation carried on in the language of light. The Cyclops with his singular gaze, the engineer with his visor, the artist with her palette, all are reminders that vision is as much about interpretation as it is about reception. And as science and imagination continue to entwine, the boundaries of sight will only grow more porous, more wondrous. Somewhere far above, photons are leaving the surface of a distant star, beginning their own journey. Perhaps, in some unimaginable future, they will reach a new eye, biological or artificial, human or otherwise, ready to translate their silent message into sight. The universe is full of such beginnings, each a prologue to a story yet untold. Silence drapes the room, and the gentle hush of nightfall brings with it a subtle magic, the magic of vision itself. You find yourself floating in that hush, your awareness turning inward, tracing the path of a single photon as it journeys from the outer world to the depths of your mind. It is a journey both physical and intangible, a voyage across the boundaries of matter and perception. As you settle deeper into this reverie, let us unravel together the intricate tapestry of light as it is not only received but truly seen. The world, for all its apparent solidity, is at heart a play of electromagnetic waves. Of these, only a slender band, wavelengths from about 400 to 700 nanometers, constitutes visible light. Within that narrow slice, every color, every shade and subtlety that graces your eyes is born. But the outside world, shining with sunlight, flickering with lamplight, does not present its riches directly to your mind. There is a threshold, a veil, and it is your own body that forms it. The story begins at the front of your eye, where light, having traversed the vacuum of space and the air of Earth, meets the cornea, a dome of living tissue, clear as mountain glass. The cornea bends the incoming light, focusing it through the aqueous humor and the lens, which fine-tunes the image, adjusting its curvature to bring near or distant objects into sharp relief. Past the lens, the light travels through the gelatinous vitreous humor until at last it reaches the retina, a delicate sheet of cells lining the back of your eye. Here, at this thin interface, the physical world ends and the world of perception begins. The retina is not a simple film, but a layered tapestry of neurons. The most crucial actors in this tale are the photoreceptors, cells exquisitely evolved to capture photons and transduce their energy into electrical signals. There are two principal kinds, rods and cones, each with a distinct role in the theatre of vision. Rods are the sentinels of shadow and dusk. Numbering over 100 million per eye, they are the specialists of low light, the ones who grant you the gift of seeing in moonlight, who whisper to you the shapes and movements of the night. But rods are colorblind. To them, the world is a tapestry woven only in shades of grey, silver, and black. Their sensitivity is almost miraculous. A single photon can be enough to trigger a response in a rod cell. This is why, in the deepest dark, when you close your eyes and press your hands to them, you may see faint flashes as your rods fire in response to the faintest disturbances. They cluster thickly in the periphery of your retina, the outer edge of your visual field, which is why you are more sensitive to movement and faint light at the corners of your gaze. It is the cones, fewer in number but more specialized, that bring color and fine detail to your world. Cones congregate densely in the fovea, a tiny pit at the center of your retina where your vision is sharpest and most vibrant. When you gaze directly at a flower's petal, a page of text, or the shifting hues of a sunset, you are seeing not with your whole eye, but with this tiny cluster of high-resolution cones. The rest of your vision is a softer haze, filled in by memory and guesswork, a canvas of impressions rather than details. But not all cones are created equal. Among them, there are three classes, each attuned to a different range of wavelengths. Some are most sensitive to short wavelengths, the blues, indigos, and violets, others to medium wavelengths, greens and yellows, and still others to longer wavelengths, yellows, oranges, and reds. These are the so-called S, short, M, medium, and L, long cones, the trinity at the heart of trichromatic vision. It is here that myth and truth begin to part ways. You may have heard, perhaps in a half-remembered lesson or a colorful article, that humans can only see three primary colors, red, green, and blue, and that all other colors are mere mixtures of these. But this is a simplification, a shadow of a deeper reality. The world of color is not made up of three fundamental paints, but arises from the interplay of countless wavelengths, filtered and interpreted by the complex machinery of our eyes and brains. Each type of cone does not see a single color, but rather responds to a broad range of wavelengths with overlapping sensitivities. When light strikes the retina, it rarely stimulates just one class of cones. Rather, every wavelength elicits a unique ratio of responses across the three cone types. For example, a wavelength of 580 nanometers, a golden yellow, will strongly activate both M and L cones, but hardly the S cones. The brain, receiving this pattern, interprets it as yellow. An emerald green, by contrast, will peak with the M cones, while stimulating the others less strongly. Thus, every color you perceive is not a simple note, but a chord, a harmony of cone responses. This is why the primary colors are not properties of light itself, but of our particular biology. If you had a different arrangement of cones, your primaries and your entire color experience would be transformed. Some animals, such as many birds and butterflies, possess 4 or even more types of cones, allowing them to see colors beyond our imagining, including into the ultraviolet. Their rainbows are broader, richer, filled with hues that have no name in any human language. The world, as seen by a sparrow or a swallowtail butterfly, is not just brighter, but fundamentally different. Within the human family, too, there is variation. Some women, due to a quirk of genetics, possess a 4th type of cone, an extra variant of the L or M cone, granting them the potential for tetrachromacy. For them, the world shimmers with subtle gradations that most of us cannot discern. A bouquet of roses, to their eyes, may reveal dozens of distinct reds where others see only one. But for many others, the tapestry of color is woven with fewer threads. Color blindness, or more accurately color vision deficiency, is not a true blindness, but a reweaving of the pattern. The most common forms arise from missing or altered M or L cones, leading to difficulties distinguishing reds from greens or blues from yellows. The world for those with red-green color blindness is not grey, but simplified, as if a few keys on the piano of color are muted or merged. This condition has deepened our understanding of color vision, revealing just how much of our perception is constructed by the brain. Take, for example, the Ishihara color test, those circles of colored dots that reveal numbers to some and only patterns to others. To a person with normal trichromatic vision, the numbers leap out in vivid contrast. To someone with color vision deficiency, the numbers may be invisible, hidden in plain sight. The colors exist, the photons reach the eye, but the neural machinery interprets them differently, blending or separating them in ways that are both mysterious and revealing. There is no correct way to see the world, only the way your biology allows. The journey from the retina is not the end, but the beginning of another, even more complex voyage. The rods and cones, upon detecting light, do not simply send their signals onward. Instead, their outputs are filtered, compared, and processed by several layers of retinal interneurons, bipolar cells, horizontal cells, amacrine cells, each performing computations, enhancing edges, detecting contrast, sharpening motion. Only then do the signals converge on the ganglion cells, whose long axons bundle together to form the optic nerve, a thick cable of living tissue that pierces the back of your eye and carries the essence of your visual world to the brain. Here at the optic nerve there is a curious gap, a blind spot where no photoreceptors exist. Yet you do not see a hole in your vision. Your brain, ever the improviser, fills in the missing information with patterns drawn from the surrounding area, with memories, guesses, and imagination. You walk through life unaware of these gaps and substitutions, trusting that what you see is what is really there. The optic nerves from each eye cross at the optic chiasm, a subtle twist that allows information from each visual field to be shared between the two hemispheres of your brain. From there, the signals travel to the lateral geniculate nucleus of the thalamus, and then to the primary visual cortex at the back of your head. Here, in the darkness of the skull, the patterns of light are translated into perception, colors, shapes, movement, depth, and meaning. But this translation is not a simple decoding. The brain does not have a screen on which to project an image. Instead, it constructs, in real time, a model of the world, fusing signals from both eyes, correcting errors, compensating for changes in lighting, and even predicting what ought to be seen. When you gaze at a ripe apple, for example, your brain combines color information with shape, texture, and prior experience. The red you see is not just a wavelength, but a memory, a symbol, a cascade of associations: sweetness, autumn, childhood. The brain's power to synthesize and reinterpret is nowhere more evident than in the phenomenon of synesthesia. For some, the boundaries between senses are porous, and the perception of color becomes entangled with sound, taste, or emotion. A musical note may shimmer with a particular hue. A word may evoke a burst of color or a sensation of texture. Synesthesia is not a defect, but a testament to the brain's creativity, its capacity to forge connections where none are expected. It challenges the notion that perception is fixed, reminding us that reality is shaped by the mind as much as by the world. How remarkable, then, that the simple act of seeing, so immediate, so effortless, rests upon such a labyrinth of biology and computation. How wondrous that the photons born in the heart of a distant star can, after their long journey, pass through your eye, spark a cascade of molecular changes in a single cell, and finally emerge as the vivid green of a leaf, the deep blue of twilight, the gentle warmth of a loved one's smile. Yet even with all we know, there remain mysteries. Why do some colors seem to glow with an inner light, while others recede into shadow? Why do certain hues evoke strong emotions, calm, excitement, nostalgia, while others pass unnoticed? And what of the colors that exist only in the mind? Impossible shades, such as reddish-green or bluish-yellow, forbidden combinations that the brain cannot resolve, yet which hint at the deeper complexity of our neural machinery. In the quiet moments before sleep, as your eyes grow heavy and the world darkens around you, consider the tapestry woven by your eyes and brain, a tapestry of asto, niching complexity and beauty, yet fragile and subjective, ever-changing with the shifting tides of biology and experience. The act of seeing is not merely a passive reception of light, but an active creation, a dance between world and mind, physics and poetry. As the last threads of consciousness drift toward dream, the question lingers: what other worlds might exist just beyond the limits of our perception? What colors, what patterns, what forms, waiting to be seen by other eyes, or perhaps by our own, in some future moment of revelation? The tapestry is unfinished. The journey continues ever deeper into the heart of light. In the silent hours before dawn, when all is shadow and suggestion, there is a peculiar clarity to the world, a kind of vision that is both literal and symbolic. It is in this hush, just before the world stirs, that the story of our quest to understand vision seems most appropriate to recount. For the journey through the illuminated pathways of the mind is not unlike a passage through darkness toward light. For centuries, the secrets of sight have been hidden behind the opaque curtain of the skull, the workings of the mind's eye elusive, mysterious, and yet tantalizingly close. Long before we could peer into the living brain, we relied on the patient accumulation of observation, the slow revelation of anatomy, and the careful deduction of physiology. The eye, with its intricate lens and delicate retina, was for generations the best understood portion of the visual pathway. Leonardo da Vinci, with his fine pen and restless curiosity, sketched its layers and pondered its mysteries, while Isaac Newton split sunlight into its spectral components, revealing the hidden complexity of color. Yet for all their brilliance, the true seat of vision, the place where photons translated into perception, remained stubbornly out of reach. It was the 19th and 20th centuries that brought the first glimmers. The invention of the microscope, and later the refinement of histological staining, allowed anatomists to see the fine architecture of neural tissue. Santiago Ramón y Cajal, the Spanish father of modern neuroscience, painted with his silver nitrate stains the delicate filigree of neurons in the retina and beyond. He saw for the first time that the brain was not a homogeneous pudding, but a vast forest of branching cells, each whispering to its neighbors in a language of electrical impulses. Still, these were static images, snapshots of a living process that could only be guessed at. The real leap came with the realization that one could not merely look at the brain's structure, but must listen to its music. The first tools to do so were crude by today's standards, but revolutionary in their time. Electroencephalography, or EEG, emerged in the early 20th century, pioneered by Hans Berger. By placing electrodes on the scalp, Berger could record the faint electrical rhythms generated by neurons firing in concert. The patterns, waves of alpha and beta, flickered and pulsed with the waxing and waning of attention, sleep, and crucially the act of seeing. When a subject opened their eyes, the alpha rhythm would diminish, replaced by the more frenetic patterns of wakeful vision. This was the first time the living brain's response to light could be registered, however coarsely, from without. EEG, for all its limitations, offered a tantalizing glimpse into the temporal dance of the brain. It could not, however, show where in the depths of the cortex these patterns originated. For that, other methods were needed, tools that could peel back the layers of the mind with precision. In the mid-20th century, the dawn of neurophysiology beckoned. Microelectrodes, fine enough to pierce a single cell, were developed, allowing scientists to eavesdrop on the conversations of individual neurons. It was with such tools that David Hubel and Torsten Wiesel began their now legendary experiments at Harvard in the late 1950s. Their laboratory, filled with the soft hum of equipment and the gentle glow of cathode ray oscilloscopes, became the site of a quiet revolution. Their subjects were cats, chosen for their large, expressive eyes and the relative accessibility of their visual cortex. Anesthetized but alert, the animals would gaze into a screen onto which patterns of light and shadow could be projected. With infinite patience, Hubel and Wiesel inserted microelectrodes into the primary visual cortex, area V1, and recorded the electrical chatter of neurons as different images flickered before the eyes. At first the signals were enigmatic, a blur of spikes and silences, but slowly a pattern emerged. Some neurons responded vigorously to lines at particular angles. A vertical bar, for instance, would set a particular neuron crackling with activity, while a horizontal one left it mute. Others responded to edges, still others to movement. Like keys on a piano, each cell was tuned to a specific note in the symphony of vision. Yet the real revelation came when Hubel and Wiesel mapped the arrangement of these neurons across the cortical surface. They discovered an elegant order. Cells with similar preferences for orientation were arrayed in slender columns, one beside the next, forming a kind of neural tapestry. Each column represented a tiny sliver of the visual world, and together they wove an intricate map, a living representation of the scene before the eyes. This discovery, the columnar organization of the visual cortex, transformed our understanding of how the brain processes information. It revealed a structure at once modular and interconnected, where each cell contributed a fragment to the whole, and the whole was more than the sum of its parts. For their work, Hubel and Wiesel would later receive the Nobel Prize. though the true reward was the opening of a door onto previously unimagined complexity. Their methods, though invasive and necessarily limited to animal studies, provided a template for future research. But as the 20th century progressed, new non-invasive tools began to emerge, allowing scientists to peer into the human brain as it went about the business of seeing. Functional magnetic resonance imaging, fMRI, was perhaps the most transformative of these. Building on the principles of nuclear magnetic resonance, fMRI detects subtle changes in blood flow within the brain, inferring neural activity from the metabolic demands of firing neurons. With fMRI, the living human cortex could be mapped in exquisite detail. Researchers would present subjects with a flickering checkerboard or a slowly drifting grating and watch as regions of the occipital lobe lit up in synchrony. These patterns of activation revealed the topography of the visual cortex, the orderly progression from the foveal center, where acuity is highest, to the periphery, where motion and broad shapes are detected. The retinotopic map, first glimpsed in the animal experiments of the past, could now be seen in the shifting colors of a computer screen, each pixel representing a tiny patch of cortex responding to a sliver of the visual field. fMRI was not limited to the early visual areas. By crafting clever experiments, neuroscientists could probe higher-order regions. The fusiform face area, for example, which responds selectively to faces, or the parahippocampal place area, tuned to landscapes and scenes. The brain, it seemed, was a mosaic of specialized zones, each contributing its own expertise to the act of seeing. These discoveries were not merely anatomical curiosities. They provided a framework for understanding disorders of vision, such as prosopagnosia, where the recognition of faces is lost, or achromatopsia, where color itself fades from perception. Yet, for all its power, fMRI is a slow and lumbering tool, its temporal resolution measured in seconds rather than the milliseconds in which neurons fire. To capture the fleeting dynamics of vision, the brain's response to a flash of lightning, the flutter of a bird's wing, scientists turned to other techniques. Magnetoencephalography, or MEG, detects the faint magnetic fields generated by neural activity, offering a window into the brain's rhythms with exquisite speed. Combined with EEG, MEG paints a picture of a brain in motion, the rapid choreography of perception and interpretation. These technological advances did not arise in a vacuum. Each was the product of decades of trial and error, of failed experiments and incremental improvements. The development of the microelectrode, for example, required the invention of materials fine enough to pierce a single cell without destroying it, and amplifiers sensitive enough to detect a whisper of voltage amidst the noise of the body. fMRI demanded superconducting magnets, cryogenic cooling, and the mathematical wizardry of signal processing. Across continents and generations, thousands of minds contributed to the gradual unveiling of the visual pathways, and still the human element remains. The story of vision research is not merely one of machines and measurements, but of people, of curiosity, collaboration, and sometimes competition. It is told in the quiet hours of the laboratory, the sudden spark of insight, the slow accumulation of evidence. It is told in the courage to question old dogmas, and the humility to accept when a cherished hypothesis must be abandoned. The illuminated pathways of the brain are mirrored by the illuminated pathways of discovery, twisting, branching, converging toward greater understanding. Consider for a moment some of the more whimsical experiments, those that seem in retrospect almost like riddles or parables. In the 1960s, Richard Held and Alan Hine devised an apparatus known as the kitten carousel. Kittens raised in the dark were placed in a circular contraption. One would walk, propelling both itself and a passive companion. Only the active kitten, able to correlate its movements with changes in its visual world, developed normal vision. The passive kitten, though exposed to identical sights, remained functionally blind. From this, we learned that vision is not a passive recording, but an active process. The brain must learn to interpret what the eyes deliver through movement, exploration, and experience. Other milestones are less dramatic, but equally profound. Psychophysicists working with human volunteers measured the faintest light detectable by the eye, revealing the astonishing sensitivity of our photoreceptors. By varying the contrast and spatial frequency of patterns, they charted the limits of visual acuity and the peculiar quirks of perception, illusions of motion, color, and form. These subtle experiments, often conducted in darkened rooms with little more than a slide projector and a willing participant, laid the groundwork for our current models of vision as a process of inference and hypothesis testing. In recent decades, computational tools have entered the stage. Computers simulate networks of artificial neurons trained to recognize faces, objects, even scenes, echoing in silico the architecture discovered by Hubel and Wiesel. These artificial systems, though crude by biological standards, offer a testbed for theories of vision, allowing hypotheses to be explored at a scale and speed impossible in living brains. They also raise new questions about the nature of representation, the limits of learning, and the parallels between silicon and synapse. As the boundaries between disciplines blur, vision research becomes ever more interdisciplinary. Optical engineers collaborate with neuroscientists to build better microscopes. Physicists refine the mathematics of imaging. Psychologists design experiments to tease apart the layers of perception. The tools grow ever more sophisticated. Two-photon microscopy, allowing the imaging of living neurons deep within the brain. Optogenetics, enabling the precise control of neural activity with pulses of light. Connectomics, tracing the tangled web of connections with electron microscopes and machine learning. Yet, for all our advances, the central mystery remains. We can trace photons as they strike the retina, map the cascade of signals up the optic nerve, chart the columns of the cortex and the activation patterns of higher areas. We can simulate, record, and manipulate. But somewhere along the way, the raw data of sensation becomes experience, the world as seen, not merely as registered. The illuminated pathways of the brain flicker with meaning, and in that flicker lies the essence of vision. The story is far from finished. Even as we map the visual cortex with ever greater precision, new puzzles emerge, enigmas that invite us to look deeper, to question more boldly. The brain, after all, is not merely a passive receiver, but an active constructor of reality, shaping and reshaping the world according to its own logic. Each new tool, each experiment, is a lantern held aloft in the vast twilight of the unknown. And so we pause, for now, on the threshold of further revelation. The illuminated pathways stretch out ahead, branching and converging, inviting us onward into the next great mystery, the transformation of sensation into the vivid tapestry of conscious sight. As night settles over the world and shadows blur the edges of familiar things, the mind's eye opens wider. The ordinary becomes otherworldly, and the quiet hum of consciousness grows louder than the day's clamour. In this hushed liminality, let us drift into the heart of vision's greatest mystery, not the physics of light, nor the mechanics of the eye, but the way seeing shapes what it means to be human. Here, in the hush between thought and dream, we can contemplate how the shimmer of photons, filtered through flesh and mind, has left its indelible mark on our art, our philosophies, and the very boundaries of our shared reality. Vision is not simply a passive reception of the world, as if the brain were a silent theatre and the eyes mere projectors. Rather, it is an active, ceaseless construction, a painter's hand, a composer's ear, a philosopher's yearning, all melded together in the twilight spaces behind our brows. Our brains seize the raw data of photons, decode wavelengths, and assemble them into the rich, continuous panorama of experience. This creative act is so seamless, so immediate, that we rarely pause to question it. Yet, woven through every moment of sight is a profound mystery, the gap between the world as it is and the world as we see it. Consider for a moment the phenomenon of color. The spectrum, for all its physics, is ultimately a story told by the mind. Sunlight, broken into its constituent wavelengths, washes over us in invisible waves. The retina's cones, tuned to different slices of this spectrum, fire in intricate patterns, but the sensation of blue, the velvety coolness of indigo, or the aching brightness of lemon yellow, these are not properties of light itself, but inventions of the brain. Where, then, does blue truly exist? Is it out there, in the world, or in here, behind the eyes? The philosopher John Locke called such qualities secondary, not inherent to objects, but born in the act of perception. Centuries later, the neuroscientists' instruments confirm the same. Color is the brain's answer to the riddle of electromagnetic energy. This subjectivity is not a flaw, but a wellspring of creativity and difference. Humans, unlike most other animals, are trichromats, with 3 types of cone cells. Our color vision is richer than a cat's, but pale compared to the 4-cone world of a parrot or the mantis shrimp's kaleidoscopic reality. Even among people, genetic differences quietly tune the visual palette. Some see more shades of red, others less. A rare few, known as tetrachromats, possess an extra cone and can distinguish colors invisible to the rest of us, a secret rainbow woven through the ordinary spectrum. And still, despite this variability, we speak with confidence of green and gold, as if these were universal, objective truths. But are they? In the cross-currents of language and culture, the boundaries of color shimmer and shift. The ancient Greeks, for instance, rarely described the sky as blue. Homer's wine-dark sea was not a failure of poetry, but a difference in perception shaped by language and habit. Some cultures divide the world's hues into just 2 categories, light and dark. Others have many words for what English speakers call green. The color spectrum, it seems, is not only a biological inheritance, but a cultural construction, a shared hallucination, negotiated over centuries and painted anew by each generation. From these shifting sands, human creativity has arisen. Artists, those sensitive magicians of light and pigment, have long probed the mysteries of vision. The Impressionists, with their broken brushstrokes and shimmering colours, sought to capture not the facts of the world, but the fleeting sensations of seeing. Monet's water lilies, vibrating in the haze of a summer afternoon, are less about flowers and more about the experience of sunlight on the retina. Van Gogh's starry nights, swirling with improbable blues and golds, invite us to feel the electric charge of darkness made luminous. In their wake, modern art pushed further still, daring to make the act of seeing itself the subject of the canvas. Yet even the greatest artists are bound, like all of us, by the physiology of their eyes and the peculiarities of their minds. The pigments of the world, the chemistry of oil and mineral, reflect only a narrow band of what could be seen, had our eyes evolved differently. The world, in truth, is awash with wavelengths beyond our grasp, the deep pulsing reds of infrared, the icy daggers of ultraviolet. Bees, with their ultraviolet vision, see patterns on flowers that are invisible mysteries to us. Snakes sense the warm glow of prey in the dark, a ghostly world painted in heat. Each creature's experience is a private theatre, a version of reality stitched together from what its senses can decipher. This realization brings a subtle vertigo. What then is real? If our brains build the world from light, and each brain tells a slightly different story, Is there a single reality at all? The physicist's answer is precise and austere. Reality, in its deepest sense, is a realm of particles and fields, of energy and probability, indifferent to human senses. But the philosopher and the artist hesitate. For them, the world as lived, the world of colour, of shadow, of form and feeling, is no less real for being constructed. Indeed, it is the only reality we can truly know. The mind's eye, in this sense, is both a window and a painter's brush. Through it, we reach outward to the world and inward to ourselves. The act of seeing is an act of creation, a ceaseless dance between what is and what could be. It is here, in this liminal space, that the great questions of consciousness arise. What is it like, truly like, to see? Not just to measure wavelengths, but to feel the ache of a sunset, the thrill of colour, the quiet clarity of moonlight on water. Neuroscience, for all its progress, cannot yet answer this riddle. We can map the pathways of vision from retina to cortex, trace the pulses of electricity that flicker across neural networks. We can even induce artificial visions using light or magnetism and watch as the mind conjures scenes from nothing. But the leap from matter to meaning, from neurons to experience, remains mysterious. This is the so-called hard problem of consciousness. Why should the firing of cells give rise to the vivid private theatre of the mind? Why, when light strikes the retina, does it become the blue of a summer sky, the gold of autumn leaves, the gentle grey of dawn? Some have argued that consciousness is not just a byproduct of vision, but its very purpose. The world, in this view, exists as an endless field of potential, a chaos of signals waiting to be shaped into meaning. The eyes gather, the brain interprets, and consciousness itself arises as the shimmering crest of this wave. We are, in this sense, not passive observers, but active participants in the creation of reality. The philosopher Kant, centuries ago, suggested that space and time themselves are forms imposed by the mind, a scaffolding on which the world is hung. Modern physics, with its strange quantum riddles, sometimes seems to echo this idea. That observation, in some sense, brings the world into being. Yet for most of us, vision remains a gift so familiar we rarely pause to question it. From the first moments of life, we are bathed in light, faces, colours, movements, the dance of shadows on the wall. We learn to recognize, to categorize, to name. The child's first word for red, the lover's gaze into another's eyes, the artist's longing to capture the impossible play of light. These are the milestones of a visual species shaped by an ancient inheritance. Our myths and stories are full of the language of light, enlightenment, revelation, the blinding flash of insight. To see is, in so many cultures, to know. But what of those who do not see? Throughout history, blindness has been both feared and revered. The blind poet, the prophet, the oracle. These figures remind us that there are other ways of knowing, other forms of reality. Indeed, the brain is endlessly adaptable. In the absence of vision, other senses grow sharper, and the mind's capacity for imagery remains. The mind's eye is not limited to the eyes themselves. It is a faculty of imagination, memory, and synthesis. Even in total darkness we dream, we remember, we create. The world of sight is only one facet of a greater whole. Art, philosophy, and science have all grappled with the limits of vision. The Renaissance painters, with their careful studies of perspective and light, sought to capture an objective reality, to trick the eye into seeing depth where there was only canvas. Yet, as they learned, every act of seeing is an act of interpretation. The shadows are never simply black, but tinged with purple, green, blue, colors invented by the brain to make sense of the world. The Cubists shattered perspective altogether, reminding us that reality can be assembled in many ways, each as valid as the last. In the 21st century, virtual and augmented realities take this further, conjuring entire worlds out of code and light, and challenging our sense of what is real. And so, as the night deepens and the world outside grows faint, we are left with the quiet wonder of the mind's eye. Each of us carries a private universe, assembled moment by moment from the raw stuff of sensation. The vision of a tree, a face, a distant mountain, these are not simple reflections, but ongoing acts of creation. The brain, in its wisdom, smooths the gaps, fills in the shadows, paints the world with colours no photon possesses. The mysteries of vision are not yet exhausted. Why do we each perceive colour slightly differently? Is there any way to know if your red is the same as mine, or if the blue of the sky to one person is the blue of the sea to another? How do memory, emotion, and language shape what we see and what we remember having seen? In the laboratory, Scienty, STS probe these questions with ever more subtle tools, mapping the brain's activity, cataloguing the chemistry of perception. But the answers remain tantalizingly out of reach. Perhaps, in the end, this is vision's greatest gift, not certainty, but wonder. The world as we see it is a tapestry woven of physics and biology, history and language, shaped by the accidents of evolution and the creativity of the mind. To see is to participate in a grand illusion, an ongoing negotiation between what is out there and what is in here. We are, all of us, both audience and creator, both scientist and poet. As you settle into the darkness, letting your own mind's eye wander across the landscapes of memory and imagination, consider the question that has haunted thinkers from Plato to modern neuroscientists. If reality is built from light, filtered through the machinery of the brain, then what lies beyond? Is there a world that exists, unshaped by perception, or is the world itself the sum of all our gazes, all our acts of seeing? The shadows grow long, the colours fade, but the wonder remains, a quiet persists. Tent glow, like the after-image of a bright day, lingered behind closed eyes. And so vision carries us onward, into dreams, into darkness, into the mysteries that wait in the dawn. The mind's eye, ever wakeful, ever weaving, traces its silent patterns, seeking always the next glimmer of light. As our journey through the luminous pathways of sight drifts to a close, may the delicate dance of light and mind linger like a comet tail, fading into the hush of space. Rest now in the quiet wonder of how your brain weaves the tapestry of reality from shimmering threads of light, and when your dreams seek new mysteries, return softly for more tales beneath the cosmic canopy.